This video is a continuation of our previous video. Again, let us see how to find the limits for the given region of integration. Look at this given integral. In this given integral, this is the region of your integration, right? So upper half of your x-axis. Now let us see how to find the limits for this given region for the integral, double integral, the function f. The order of integration is dx dy. As I told you before, if it is dx dy, we are going to shade the region of integration by horizontal lines. So before that, let us write the endpoints. This point is 2, 0, and this point is 0, 0, and this point is 1, 1. After finding this endpoint, let us go for shading. Dx dy, it means we are going to shade it by horizontal lines. When I shade by horizontal, so I will start at the left side, which is a blue curve, to the brown line. So blue curve to the brown line, blue to brown, blue to brown, blue to brown. Until the end, the color varies from the blue to the brown line. So look at the value of x in the blue curve. The value of x in blue is x is equal to y power 2. This is the value of x. So x equal to y power 2. When I stop at the brown line, what is the value of your x? x equals x equals 2 minus y. So the value of x is 2 minus y. Now look at the line. The line varies from, this is your x-axis. The equation of x-axis is y equal to 0. So from the bottom line until this end. So when we start, the value of y is 0. When we stop, the value of y is 1. So the limit for this region of integration for the order dx dy is integral 0 to 1, integral y power 2 to 2 minus y. I hope it is clear to everyone. Now let us see the limits for the order dy dx. So order is dy dx, right? So this point of intersection is 1, 1, right? So when you are going for integrating the order dy dx, we are going to shade the region by vertical lines. So look at the shading. So I will start at the bottom line, which is your black line, the equation x-axis, black line to the blue, black line to the blue, black line to the blue, black line to the blue. After this point, the limit goes from the black line to the brown. So now there is a variation of color. So in our previous example, we don't have this type of problem. Now this problem comes in a special case. So when you have the variation of color, when you are shading, that means the given region is splitted into two integral. So you are going to add a one more integration for the different color, right? So the first integration is for the color from black to blue, and the second integral for the color black to brown, right? So this is the point of changing, right? So now in the first half we have black color to the blue color. So what is the value of y in the black color? In the black color, the value of y is 0. So when I stop in blue color, what is the value of your y? Y power 2 is equal to x. That means the value of y is square root of x. So as we looked on our previous example, when you take the square root value, it will go for a positive and negative, and this is the upper half of your x-axis, so that means y is positive. In the lower half the value of y is negative, so we take the positive square root of x. Now look at the line. The line is moving from this point to this point. What is the value of your x? 0. And when we stop, what is the value of your x? It is 1. Now, in the next half, the limit varies from the black color to the brown color. What is the equation for the black color? Y equal to 0. What is the value of your y in brown color? Y equals 2 minus x. So this is 2 minus x. Now what is the starting point? This is your starting point, and we stop here. When you start, what is the value of your x? It is 1. When we stop here, what is the value of your x? It is 2. So in the case of order dy dx, the given region is split into two regions. The first region for line to the parabola. The second region is line to the line. So in this type of problem, if we go for an order dx dy, that is better than dy dx, because in dx dy we got one integration to evaluate, but in the case of dy dx you have to evaluate two integration to get the actual value, right? I hope this explanation is clear to everyone. Now let us look on to the next example. Look at this example. So we are going to find the integration for the order dx dy. So the end point is 4 comma 4, and this point is 0 comma 0. When it is dx dy, we are going to shade it by horizontal. So blue color to the brown color, blue color to the brown color, blue to brown, blue to brown, blue to brown. Until the end, the variation of colors are blue to brown. So when we start at blue, what is the value of x? So y square equal to 4x. That means x is equal to y square over 4. So when we start at blue color, the value of x is y power 2 over 4. When we stop at the brown color, the value of x is square root of 4y. This side x is positive, so we take positive square root of 4y. Now look at the line variation. It start from the lower and it stop at the upper end. So at the lower end, what is the value of your y? 0. At the upper end, what is the value of your y? 4. So the outer limit will be 0 to 4. Now let us see the same problem for the order dy dx. That means we are going to take the vertical strip. So the order of integration, we are going to change it to dy dx, right? So vertical. So when I go for drawing the vertical lines, I will start at brown color, I will end at blue color. Brown to blue, brown to blue, brown to blue, brown to blue, brown to blue. So the starting point is the brown color and the end point is the blue color. What is the value of y in the brown color? Y equals x power 2 by 4. So x power 2 by 4. When I stop at blue color, what is the value of your y? Y equals square root of 4x. In this region, the value of y is positive, so we take square root of 4 times of x. Now the line moves from the left side to the right side. When we start at left side, the value of your x is 0. When we stop, the value of your x is 4. And this is the order, this is the limit for the order of integration.